I'm Saurabh, and our project is attendance smart system, in which our goal is to make a model such that it takes the input from the user as a photo and predicts all the faces in the photo, recognize them, and tell their names. Not only just tell their names, but also to link that model with an Excel sheet, and it will automatically update the names in the Excel sheet for a given data frame. So we are using YOLOv8 version to train our model. So in starting, we are just importing few of the libraries that are required. Ultralytics is a library in which the actual YOLOv8 model is defined. Gradio, what is Gradio? Gradio is an UI tool that can be used by the programmers to test their model. Like for example, I'm ready with my model, but I'm waiting for the UI to get developed. So basically, it provides a temporary UI for you, from which you can check whether the model is working good or not. So you can first run it. I are done with installing the required libraries. Then we are using this code to mount our Google Drive, in which we have our actual dataset to our collab notebook. So once you are done with running this code shell, you will get your drive over here, just like this. In this my drive, and here all of your content will be displayed, like this dataset, and this is our actual dataset that we collected, and this is data.yaml. Once you have uploaded your dataset, so you have to change the path of train, val, and test files over here according to this. You can just go there, copy the path, and paste it here. Once you are done with that, then you have to just import the YOLO module from the Athletics, and this part of code, what it is doing, that once after detecting we get the result. From that result we can fetch the name of the class to which the object belongs. So it will be used, it will be explained later. And Gradio, we are renaming it as GR. So this is a pre-trained model of YOLOv8, on which we will be training our custom dataset. So once we run this also, now this line is to train your model. So just you have to give the path of data.yml that is in your drive, here in dataset over here. This is the path. So you can copy the path and give it the path. And epochs, you have to tell the number of epochs you want to run. So what epochs is, for example, I have a dataset. So for 200 epochs, it will run 200 times, and it will learn on itself that what the actual photo it is, and it will train over that many epochs. And you have to give the image dimension over here. So our image dimension is 640. Once you are done with training your model for a certain number of epochs, after that you will get your model trained as best.pt in waits, in train, detect, run in content. So go to run, there go to detect, in train, there will be wait. So there are these two files. This best.pt is the latest model of the latest model that has been trained over your dataset, and the last.pt, it is the last model that was used to train your dataset. So we will be using this model to detect the objects in the photo. So we are storing that in model, and this is used to validate your model. And once you are done with this, it will tell about these things, about what's the precision of the boxes and stuffs like that. And once you are done with that, you have to give the source path. For example, here in my drive, I have few of the photos, like these two. This Mava and Mava 1. So these two are the photos. You can see that there are 4 people. And if we run, then it will tell, okay, sorry, Mava is this one. There are 4 people, and we will make this Mava path. Once we run that, it gives the name of the students that are there in that photo. And there is one more photo, dot 1. There are 2 people, Nikhil and Sai. And if we specify that path, it will go there, detect the objects in the sense of the faces, and give their names like this. And we can do the same thing using the Gradio. So what actually Gradio was, that once we run this code, it will provide you a UI, a temporary UI, where you can test these things rather than waiting for a UI to get built. So you will get a UI like this. From here you can directly use the photo that you want to detect. For example, there is one style. If I upload this and submit, it will give me the result. There is a guy, one side here. I upload one more photo. This Shaman is there. If you submit this will give Shaman. So how this Gradio actually works is, you have to define a function. So this is the code of the Gradio, in which the function we are giving, which function we are using input. What we are taking as input, we are taking an input. What we are giving displaying as output is text and title, that is of no use, and then launch. Once it have been once your code reaches to this part of code, it automatically calls the function. It does its work. That what actually the function doing is fetching the names of the class of the detected object, and then it will give in a list of tuples, and it will return that as a string. So once it will return, it will show that as a text. So that's what. Our model is not yet fully working. There are many flaws in it. Like later at a very end stage, we got to know that YOLO is basically best for object detection rather than object recognition. So we are facing some issues. For example, if I am using some other photo of mine, say this photo, open and submitting. So there are some flaws, that it is saying that there is one Saurabh and one Sanchit, but there is no Sanchit over there. So there are a few flaws in this. We are working on it, and like we got to know that YOLO is actually for object detection. For example, if you want the face, it will detect the face very accurately and very fast. But when it comes to the recognition of face, recognizing whose face it is a little difficult. But we are working on it. We got to know a few hours back only that we can integrate this YOLO with FaceNet and face recognition, so that our result will be more accurate, more fast, and on the point. So yes, that was our model. And also, if you want, we have given our GitHub link over here. Just go on main. In this main, you will find the test model. There you will get the dataset, the detect, over which all the files are there. Okay, I forgot to show you the files. So when you go to the run, detect, and train, so all these are the files that the model has predicted and learned. For example, if you go to result.csv.png, if you go to png, so it is giving all the what's the laws and stuff like that, and matrix precision, what's the precision, actual precisions, what is the area per cell, the center of the each box, whether it's actually matched, and with what percentage it matched, it shows that. And also the photos, all the graphs, basically whatever the model has learned, it shows you as an interface. You are giving these photos. So these are, I have given all these files over here. So if you want to train yourself on this dataset, what you have to do is just download this this Jupyter notebook on your system, upload it to Google Colab, and use these datasets and detect. Just upload these two, and I showed you, right? You have to change this path. So you have to give the accurate path of the directories that it is asking for, and you can run directly from here. But if you don't want to just train, because I have given also files, if you go here and detect in train, weights. So everything, the only thing that this model requires is this best.pt. So this best.pt file in weights, I've given this. You just have to upload this file into your Colab and run the detect this part, this cell. So it will automatically take that best.pt model from the uploaded file, and it will directly do this detection part, so that you don't have to train that model again. So yeah, that's it. Thank you. And front end part will be explained by one of my teammate. Thank you.